Okay, let's say you've been given this quadratic here. 3x squared plus 2x minus 8. So, let's just sketch it roughly. So when x is small, it wants to do this straight line here. So it's minus 8 and then a gradient of 2. So it has a steepness of 2 here. Okay, so roughly speaking, it's like that. And then when it's big, it wants to do this. It wants to do the quadratic. It wants to do the quadratic curve like this. So try and take the average of the two. So it's good. We're going to guess the quadratic to look something like this. Okay. So in the past, I've shown you how you can work out this point here and this point here. So now let's try and work out this point, the lowest point. Okay. So to do this here, to do this here, rewrite this whole thing. To do this, rewrite this whole thing here as this. Hang on, let me just copy it down here. Y equals 3x squared plus 2x minus 8. Okay. To do this, just use you got to use what's called completing the square. So it's similar to that thing that we did earlier. It was this here and then this squared and then minus blah 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 blah. So we can use this technique here and apply it to this scenario here in order to find this point here. I'm just going to do it and then hopefully you will learn by watching. So now we don't want the coefficient. Well, we want the coefficient of x squared to be 1, but at the moment it's 3. In the past, we set y to be 0 because we wanted to find out these 2 points. You see, the reason why we set it to 0 is because the y value at these 2 points will be 0. So we put 0 in here, and then this will become this. Plus 2x, and then we can divide everything by 3. So the 3 here disappears, and then 0 divided by 3 is 0. Well, we can't do it. In this scenario here, we can't set we can't set y to 0 because you see this thing here represents the y here is going along here. You see it's 0 here, but by the time it gets down here, it's no longer 0. So we can't set it to 0. You see, when it gets to up here, then you can set it to 0. But down here, the y value is not 0. So we can't just simply write 0 in here and then use that same method. So here in order for you to work out this bit here, you can't just set it to 0. Okay, so let me just write this down again. So at the moment we've got y equals 3x squared plus 2x minus 8. Okay, this is what we've got here. Okay, the way we do this, we can't just put y equals, we can't just put 0 into the y. So we're going to rewrite, we're going to use this method. Take the 3 out. Okay, so it's like this. Plus 2 over 3x and then minus 8 over 3. Okay, so what I'm trying to say is that this thing here is the same as this thing here because if you multiply this out here, you will have 3x squared, and then this times this here, well, it's going to be 3 gets multiplied to the top, so it's going to be like this. Hang on, 2 times 3 over 3x in effect, because you're timesing a fraction, so it gets multiplied to the top. But these two are the same, so they kill off each other, giving you 2x. You see, this is 2x here. Okay, and then when you come to get this and multiply with this here, well, it would be minus 8 times 3 over 3. Now these two would kill off, leaving you just minus 8. That's why you've got this 8 here. What I'm trying to say is that this thing here is exactly the same as this thing here. But the good thing is that the coefficient of x squared is 1. The coefficient is 1. So let's just ignore the square brackets and just concentrate on what's in the inside here. Okay, you see last time we just set y to 0 and then divide everything by 3. So 0 divided by 3, it will neatly stay as 0. But we can't do that. We can't do that here because the y value here is not 0. So we can't just set 0 to y. Well, anyway, that's why we have to take the 3 out. Take the 3 out and then just deal with what's in here. Okay, so we've taken the 3 out. And let's just concentrate on what's in the middle here. So it will be this here. Okay. Now do the completing the square thing on what's inside here. So rewrite this. Rewrite what's in here in the form of x plus whatever squared, and then plus whatever here. Rewrite what's in there in this form here. Okay, so it would become this x. Well, I'm going to need half of this here, so it's going to be plus 2 over 6. Okay, because I'm going to need half of it. So well, it's going to be this. It's like this, and then I'm going to need, because I need half, I've got to divide it by 2. This gets multiplied to the bottom. That's why it's 6. Okay, well anyway, it will become this here squared. Okay, but then this thing, oh sorry, there's no x here, sorry. So it becomes this here. Okay, and then well, when you come to multiply this, you right at the end, well, if you do this here, hang on, times by itself here, x plus 2 over 6 here. Well, later on you're going to get this times this here, which will be 4 over 36. So this is your rubbish here. You immediately get rid of the rubbish, which is 4 over 36, and then we'll take that thing down, minus 8 over 3. Okay, so now well, merge these two together, merge the two fractions together, these two fractions here. So let's times top and bottom here by 12. Okay, so this here would become, hang on, 3 square bracket x plus 2 over 6 squared, and then minus 4 over 36 minus 96 over 36 here. Now the two denominators are the same. We can merge them. Okay, so this will become 3 square bracket x plus 2 over 6 squared, and then minus 4 minus this, so it will be minus 100 over 36. Okay, this here. Okay, now let's just simplify the two fractions here. So here let's simplify what's inside here. So x, well, 2 over 6 is a third. So let's simplify this, a third. This, and then well, even and even. So let's divide top and bottom here by 2. Okay, let's try and simplify this. 100 over 36. That's the same as 50 over 15 plus 3, 18 here. Let's even. So let's divide it even further. So divide top and bottom here by 2. So this will become this. Okay, so this thing here becomes 25 over 9 here. Okay, so now we've got this thing here. So what we're trying to say is that this thing here, this our original equation here, can be written as this. You see, this here seems a lot more complicated, but it's a lot more useful because because you see now in this form here. Hang on. Let me just draw the graph here. You see, the smallest point on this line here, the lowest possible value on this thing here is when this whole thing here equals 0. Okay. when this thing here equals 0, this would be minus how? Just accept. I know this is hard to accept, but just for the time being, because this video has been dragging on for a bit, just accept that the smallest value here is when this thing here is 0. Okay, so that will give you this thing here. I haven't explained why. Well, just accept for the time being. So that this thing here is 0. That's the smallest possible thing. So hang on. Let's say our quadratic. Let's say it looks something like this. The smallest value will be when this thing here is 0. So this will be minus 25 over 9. Okay. So you see, when you make this to be 0 here, that will give you the smallest value for y. I haven't explained why, but for the time being, just accept it. Okay, now it's 3 times this here, so times that by 3. So this here will be minus 75 over 9. You see, this point here is actually minus 75 over 9, and the thing here would be when well, in order for this to be 0 here, you've got to make this to be negative a third. Negative x. You had to put a negative a third into the x in order for this bubble to become 0. So this bit here would be minus a third. Okay. The only thing that I haven't explained in this video is that why this has to be 0 in order for the y to be at its minimum. It's that y is at its minimum when this bubble is 0, but I haven't explained why, so I will do that in the next video. Okay.